Look, we've literally all been there. You're staring at your screen at 2 a.m., a critical deployment is just hanging there, totally stalled out. Your stomach kind of drops when you check the logs and see that agonizing access denied error on what should be a completely simple file upload. It is beyond frustrating when these stalled workflows hold up your entire production environment, right? Well, welcome to this explainer. Today, we're going to transform that frustration into absolute mastery, because this is your ultimate guide to solving the Amazon S3 access denied error when calling the PutObject operation.
Okay, let's dive right in and introduce the real antagonist of our story here, the dreaded 403. When you see that access denied message pop up in your terminal, what you're actually looking at is an underlying HTTP 403 forbidden response coming directly from Amazon S3. It's a completely blunt rejection. Basically, S3 is looking at your request, knowing exactly what you want to do, and simply saying, no way.
And man, we all know the catastrophic chain reaction this sets off. When a PutObject operation fails, your whole infrastructure feels the shockwave. Deployments just halt in their tracks. Your beautifully orchestrated CI/CD pipelines completely stalled. User-facing application uploads break, which obviously leaves your customers super frustrated. Even Lambda functions might fail to initialize because they can't read their deployment packages. And honestly, the most terrifying part? Backup systems can silently skip writes. Yeah, leaving you totally exposed without you even realizing it.
But hey, don't panic, we've got a system to fix this. Here's our roadmap for this explainer. We're breaking this down into 6 steps. 1, the 403 forbidden error. 2, the S3 layered authorization model. 3, IAM and bucket policies. 4, KMS and organizational controls. 5, ACLs and object ownership. And finally, 6, pro tips for troubleshooting. All right, let's get into it. Section 1, the 403 forbidden error.
So the very first thing you gotta understand is that your request didn't just get lost in the void, right? It actually successfully reached S3 over the network. The issue is that S3 actively refused to write the object. This denial almost always traces back to either a missing permission or an explicit deny. Now, an explicit deny is this heavy-handed security rule that overrides absolutely any allow permissions you might have. It immediately blocks the request. Think of it as an absolute, non-negotiable stop sign.
Moving right along to Section 2, the S3 layered authorization model.
Okay, here's the massive paradigm shift you need to make right now. Your S3 upload is not malfunctioning. It's actually just being blocked by a highly robust layered security funnel. You really have to troubleshoot this from the inside out. Step 1 is checking your local IAM. Step 2 is the bucket policy. Step 3 is KMS encryption. Step 4 is organizational controls. And Step 5 is the outer rim, the ACLs. The absolute golden rule you have to remember here is that passing one layer does not guarantee success at the next layer. You literally have to pass through all of them.
So let's unpack those inner layers. Section 3, IAM and bucket policies.
Starting right at the very center of our funnel with Step 1, you've got to confirm that your IAM identity is actually allowed to perform the S3.PutObject action. I know, it sounds super obvious, but you really have to check your baseline. Verify that the active AWS profile you're using locally, or the role your instance assumed, or even those temporary credentials you were handed, verify they actually contain that specific permission. Look, if you don't have the baseline key to the front door, you're just not getting in. But let's say your IAM policy looks totally flawless. You've got the right permissions, so why on earth are you still getting a 403? Well, you move to Step 2, bucket policy blockers. The bucket itself can actually set traps that silently reject an upload. You really need to keep an eye out for deny statements based on things like IP addresses or VPC endpoint restrictions. Or maybe the bucket policy requires specific encryption headers that your CLI request is just missing. It could even have complex conditions blocking the upload based on tags. Which brings us to this absolutely crucial point. A bucket-level deny always wins over an IAM allow. This is a non-negotiable, hard and fast rule in AWS security. Honestly, it doesn't even matter if your personal IAM user has full-blown administrative privileges over the entire AWS account. If that bucket policy has an explicit deny that matches your request, you're getting blocked, period.
All right, next up, Section 4, KMS and organizational controls.
Now, there is a massive potential gotcha here regarding encryption. If your bucket is using SSE-S3, which is just standard AES 256 encryption, it doesn't involve KMS at all. There is literally no key policy to check, which means you get to completely skip this troubleshooting step. But if the bucket requires SSE KMS, well, the whole game changes. SSE KMS requires strict checking of both your IAM permissions and the resource-based KMS key policy itself.
If you're going the SSE KMS route, check this out. A perfectly valid IAM policy that grants S3 PutObject is still going to fail with a 403 if you're missing a couple of very specific rights, namely KMS generate data key and KMS decrypt. See, the bucket is trying to encrypt the file you're uploading, but you don't actually have the permission to use the encryption key. So, you've got to check both your IAM user policy and the KMS key policy to make absolutely sure you're granted access.
Okay, so let's say IAM is good, the bucket policy is good, and KMS is perfect. What is next? Well, step 4 is checking organizational controls. Sometimes higher-level governance can silently crush your local permissions. We're talking about service control policies, or SCPs, which can block actions at the entire account level. Then you have permission boundaries, which basically set a hard ceiling on what your IAM entity can do, regardless of its assigned policies. And finally, session policies can limit permissions when you assume a role. If you are totally stuck here, you might need to go ask your cloud admins if an SCP is secretly overriding you.
Which brings us to the final layer, Section 5, ACLs and Object Ownership.
Now, a huge, modern S3 lifesaver is Bucket Owner Enforced. This is a specific S3 ownership mode that completely disables those legacy access control lists, or ACLs. If your bucket has this turned on, you can go ahead and breathe a huge sigh of relief because it simplifies literally everything. The bucket owner just automatically owns everything written to it. But, and this is a big but, if this setting is not enabled, especially during cross-account uploads, you just added another massive layer of complexity to your troubleshooting.
Because, you see, if legacy ACLs are still active, a missing ACL header can trigger an AccessDenied error right out of nowhere. If a cross-account bucket policy requires you to hand over ownership of the object, your PutObject request absolutely must include the header bucket owner full control. Without that exact header at your code or your CLI command, S3 will halt the whole shebang, even if your IAM, KMS, and bucket policies are perfectly configured. Crazy, right?
Finally, Section 6, Pro Tips for Troubleshooting.
Listen, if you take absolutely nothing else away from this explainer, treat this CLI command like a golden mantra. AWS STS get caller identity. Just run this immediately the second you get a 403. It definitively tells you exactly who the active caller is. Honestly, so much of the time, developers are tearing their hair out over policies only to realize their terminal is secretly using a totally different AWS profile, or maybe an expired assumed role. This one command resolves that identity confusion instantly. It's a real game changer. And when you need to stop guessing and start actually knowing what's going on, you turn to AWS CloudTrail. CloudTrail is basically your ultimate truth teller here. Don't just sit there staring at the terminal. Go over to the CloudTrail console and search for those failed PutObject events. Look closely at the AccessDenied evaluations. Check for any KMS authorization failures. The JSON payload and a CloudTrail error log will very often tell you the exact policy or the exact missing permission that is responsible for blocking your request. So, the absolute crucial point to leave you with today is this. Next time your pipeline halts at 2 a.m., which layer are you going to check first? Remember, S3 isn't malfunctioning, it's just protecting data through a really logical, layered funnel. Works systematically from the inside out. IAM permissions, then bucket policy, then KMS keys, organizational controls, and finally, ACLs. By using this fast, predictable methodology, you are now completely empowered to fix those broken deployments, unblock your pipelines, and maybe, just maybe, get back to sleep a little bit faster. Thanks so much for joining me on this explainer, and happy troubleshooting.